In some rare cases, an IP polygon is not provided for the definition of the plan view of an alignment. But instead, the consultant provides a list with information of individual alignment elements that can be used also in ABES geoDes. This video talks about these rare cases and the input conventions for such information. So here is ABES geoDes, and on the screen here I have the input dialog for a road alignment and the plan view definition for IP polygon information, the points, easting and northing information, and rounding data over here on the right. If this is not available and instead we have the information about the individual axis elements, we can input a new axis, giving it a name, axis by element, and I select axis by individual elements instead of axis by IP polygon. And if that comes up, when that comes up, we see that the plan view dialog differs from the usual look. And in this video, we are going to work with the input by element version of the plan view input for our road alignment. So let's enter our first line in this table of axis elements. The first line serves the purpose of defining a starting point, and I'm going to start at 0, 0. And if we want it, it also serves the purpose of defining a starting direction, and I'm choosing 30 degrees here. Let's put another line, and in this line and every subsequent line, what we do is we define the type of element we wish to insert, and we also define the endpoint of that element. So P2 at 100 defines the endpoint of my element, and I can select here, and I'm going to select an arc. So what we have in our first line is a starting direction, and our second line already defines our first element, an arc ending at 100 and 100. Let's draw that up. So here we see that we are starting at 30 degrees, and then the arc goes up to point 2. If we change the starting direction to, let's say, minus 10 degrees, the arc changes accordingly. We have a different starting direction now. The endpoint remains the same. So let's look at the available elements here. We have straight lines, we have an arc, we have a transition curve going into an arc, a clothoid or spiral curve, and we also have a transition curve, a clothoid or a spiral curve, coming out of an arc and back to a straight. And we have cubic parabolas leading into an arc and cubic parabolas leading out of the arc and back to the straight. So for every axis element that we wish to add to our alignment, we define the endpoint and the type of the element. As it happens, each element is added to the alignment with a common tangent at the starting point, and this tangent, along with the endpoint, which we provide in every new line, is enough to fully define each of these elements. Typically, consultants will provide a host of information for each axis element, radii, lengths, and so forth, but they would always provide the endpoints, and this is what we need for the input here in geoDes. So let's assume that we have compiled a list of the endpoints from the data we have received from our ABES alignment designer, and let's assume we've pasted that into Excel just like I've done here. Let me copy that information and go back to my little geoDes project here, extending this list and pasting it into here, and then cleaning that table. So I'm assuming that this is data that we have received from the road designer. We are starting with a straight line, and as we have this second point, the end point of the line here as well, we don't even need the starting direction because the 2 points already define this direction. We are going into a spiral curve and into an arc, and another spiral curve back to the next line, another spiral curve, another arc, another spiral curve, and another straight line, and so forth and so forth. Accept that, and here we have the resulting road alignment, road axis. And if we want to have a look at those resulting elements, we can click on the preview button here and we get the quick report, a tabulated report of our alignment, straight line, clothoid, arc, and so forth, starting point, end point, and all the other information that has resulted from geoDes calculations. In conclusion, if we cannot get hold of an IP polygon for our alignment, or if an IP polygon is insufficient to describe our alignment, which also happens, the next best option for us is to get a list of all the axis elements from our road designer. From that information from the road designer, we pick the endpoints and feed that into geoDes, together with a specification of what the elements are, arcs, spiral curves, straight lines, and so forth. geoDes will be able to reproduce this axis and, just like we see here, meet the specifications from the road designer. All the other inputs, the elevation, the axis points, the secondary axis, are the same as for the IP polygon, and we can work with this axis in the same way as we would have with an axis that's based on an IP polygon.